All right, now we're going to talk about the third and fourth technical advances, which have to do with the system of how we're dealing with the exhaust. Okay? The low pressure system, low temperature system, and the losses in the condenser. So one day, again, the way that ideas happen when you're thinking about things all the time, I came up with an idea that I did not know if I could make work or not because it's not standard engineering, right? I came up with the idea of eliminating this altogether, okay? Not using a boiler feed pump, eliminating the condenser altogether, and creating a special system that was designed to take the turbine exhaust that has still got some steam and some liquid in it, because the low pressure system that we're using, part of the way that you make a low pressure system more efficient is to use what's known as a semi-condensing turbine. So some of the condensation is now happening in the turbine, and you're actually capturing some of that energy in the turbine. But the rest, why couldn't we build a biphase pump, a pump that would pump both a gas and a liquid, okay, and take that and pump it directly back into the system so that the cycle was a little bit different. The cycle was the heat making the steam. The steam goes to a semi-condensing turbine. The biphase exhaust, which is somewhat liquid and somewhat vapor, goes directly to a special pump, and that special pump pumps it directly back into the array, the parabolic trough array. So the cycle then does not have a condenser, and the boiler feed pump is different. That's what optimized reinjection is about. It takes the wasted heat that is normally wasted here, okay, and it doesn't waste it anymore. Okay? It simply re-injects it. That's where the term reinjection comes from. Optimized is because in order for this pump to work pretty well, you have to optimize the percentage of the vapor to liquid. So optimized reinjection is about designing a turbine that is able to have about 50% condensation, about 50% vapor coming out, and then re-injecting that. So that's what optimized reinjection does. This is a significant improvement in the efficiency of this system because the condenser losses go away. All right. As you're pumping stuff around, you're going to radiate some heats, but those are the only out into the environment through insulation. Insulation is not perfect, but those are the only losses in this system. Optimized reinjection as a method of dealing with the turbine exhaust is how we get this system to become significantly more efficient. It has a big, big, big effect. You're about to go through and see an array of pictures. These pictures all have legends on them, and you'll be able to see what it is we're talking about. Okay? What you see here is our prototype. You see the top is the turbine. Down in the middle is the optimized reinjection system. There's also the generator. The boiler's in back. You can't see it in this view. In this view, you can see the back end of the turbine. You can see the top of the boiler. You can see some of the instrumentation that we used. Again, here you see the boiler without the boiler shroud. All of those tubes that constitute, in the center tube, that's the boiler. In the middle, you see the optimized reinjection. At the bottom is the generator. At the top is the turbine. Here again, you see the top. At the top is the turbine. You can't see any of the inside of the turbine because it's inside, but you can see the boiler. You can see the coils coming out of the boiler. Again, this is another view of the same thing. The back end of the turbine, the boiler, the steam going into the turbine.